To go a little bit early today because I have a meeting. I apologize that the thing cut off yesterday. I don't know why it did that. I'll keep a closer eye on it today. It's really weird, but um, anyway, you can see this red dot up here should stay on. Um, and yeah. Oh, and one thing I mentioned math tricks in my description. All I meant was like uh, if I want to like Copilot knows these math formulas like sum of squares from 1 to n, and I do that. Um, and okay, so this is what I meant is that so it's doing a sum comprehension, right? But if I say uses a clever mathematical formula, um, then it actually uses the clever mathematical formula. I thought that was cool that like if you think there might be a closed form solution for something, then you can get Copilot to give it to you. So I appreciated that. Um, Good. So um, yeah, let's look at the problem. I need to get it done fast because I have a meeting in like 50 minutes, so I can't take longer than that. Barely reach the safety of the cave while the whale smashes in the cave mouth, collapsing it. Sensors indicate another exit. It runs to your depths. You should press on. You notice that the 4-digit 7-segment displays are malfunctioning. They must have been damaged during the escape. You'll be in a lot of trouble without them. You better figure out what's wrong. Each digit is rendered by turning on or off any of 7 segments named A through G. Okay, so to render 1, only segments C and F would be turned on, and so on. The problem is that the signals which control the segments have been mixed up on each display. So we're going to still try and display numbers, but these wires are connected to segments randomly. Worse, the wire segments are mixed up separately for each 4-digit display. All the connections within a display. So there's 4-digit displays. So you might know that only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. The only digit that uses 2 segments is 1, so it must mean segments C and F are meant to be on. It's just that information. You still can't tell which wire goes to which segment. For that, I need to click more information. For each display, you watch the changing signals for a while. Make a note of all 10 unique signal patterns that you see, and then write down a single 4-digit output value. Using the signal patterns, you should be able to work out which pattern corresponds to which digit. For example, here's what you might see in a single entry in your notes. Each entry consists of 10 unique signal patterns, a pound delimiter, and finally the 4-digit output value. With an entry, the same wire segment connections are used, but you don't know what the connections actually are. Unique signal patterns correspond to the 10 ways the submarine tries to render a digit using the current wire connections. Because 7 is the only digit that uses 3 segments, 7, blah, blah, blah. 4 is the only. For now, focus on the easy digits. Consider this larger example. Digits 1, 4, 7, and 8. Using number of segments, you'll be able to tell which combination of signals correspond to those digits. Counting only digits in the output values. For it after on each line, there are 26 instances of digits that use a unique number of seconds. And the output value is how many times do 1, 4, 7, or 8 occur. Okay, so let's figure this out. Raw equals this. Um, um, okay, and so let's see. This is going to be from data classes, import data class. I'm worried this will take me more than the time I have allotted, and so I'll have to do something else. And so what I want to do is I want to, no, not a layer, 4-digit output. So what do I call that? A 7-segment display. Class display, and a display, and it's going to be a data class, class display. Actually, let me count. what did we call this? Call it count 1478. That's funny, but that's not it. So what I need to do is say digits equals raw dot split on a pipe, and then a split. It's raw dot split on the pipe, and then -1, and then a split. And then what I want to do is return some len digit in, and he said choose a unique number of segments, right? So 3, 4, 2, and 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, and 7. Turn some len digit in 2, 3, 4, 7 for digit in digits. And so now what I want to do is, let's take this first example. Well, I won't do that. I'll say, let's say displays equals raw dot split lines, and then assert that sum of count 1478 display for display and displays equals 26 instances, so that's 26. And then in part 2 they're going to make me figure out the rest, so I'll need to figure that out. But let's run this unit test and see if it works. Python do8.py, that works. So let's get my puzzle input, and do8.text, save it, and then go back to here and say if name equals main, raw equals open data do8 dot text dot read, displays equals raw dot split lines, and then now it knows what to do because it's copying from before. So that's that assertion passed before, I thought. Let me go back and look and see, unless I failed to save. For display in displays, print that. So no, that should be 2 because 7 so that's 4. So what did I get wrong? try this one more time. I screwed something up. Okay, well, it looks like my split logic is wrong. So, what is this? No. Okay, so that looks right. Did I type something wrong? Um, I don't understand what I'm doing wrong here. Is it just that this one got copied? Oh, seriously? Is it that I copied this wrong? Ah, that's so stupid. Okay. So, basically my code was right, but when I copied and pasted for my unit test, that was not right. So this says 245, so let's try that. That is the right answer. You should be able to determine the remaining digits. Okay, so the mapping only makes sense in the following. So unique signal patterns will correspond to the following digits. Then the 4 digits, the output value can be decoded, therefore the output value following the same process, etc. Adding. Okay, so this is this is what we need to do. So now we need to decode, which is raw string, and it's going to return an int, right? So the digits part is right. Coded digits. And then let's say mapping equals this. Okay. And so 4-digit and encoded digits. If len digit equals 2, then mapping digits, let's say sorted digits, I want to do these in alphabetical order, that'll be easier, equals 1. Elif len digit equals, what was it? 3. Mapping sorted digits equals, what did we say, 7? len digit equals 4. Mapping sorted digit equals, what was the one that had 4? That was 4. And elif len digit equals 7. Mapping sorted digits equals 8. Okay, and so now do the rest. And so so let's puzzle this out. So 1 we've got, 4 we've got, 7 we've got, and 8 we've got. Okay, and so and let's see how many each of these have. 0 has 1, 2, 3, 4, 5, 6. 2 has 5. 1, 2, 3, 4, 5. 3 has 5. 5 has 5. 6 has 1, 2, 3, 4. 6 has 6. And 9 has 6. Okay. So we need to figure out the 5s and the 6s. There's probably some smart way, but I'm just going to kind of puzzle through these best I can. So we know that whichever one is in the top is A, and that's really not that interesting. We know that, so we know the one, so that is a C and F, C and F, C and F, C and F, C and F. And so nine has both C and F, that has just F, both C and F, just C, both C and F. Okay, so we can do the following. CF equals next D for D in encoded digits if len D equals 2. How did it know to do that? I don't know. So basically, these are C and F, okay? And now and let's say remaining equals D for D in encoded digits if D not in mapping. Okay, and so now of the remaining, so this should have C and F, just C, C and F, C and F, C and F, just F, C and F. Okay, so so let's say okay, just first equals sum CF0 in digit and CF1 not in digit for digit in remaining, and just second equals actually no, I don't want to do first equals digit for digit in remaining if CF0 digit and CF1 not in digit. This is probably like a really stupid convoluted way of doing this. Just second equals yep, and then so like I said, if len of just first equals 1, then that means first equals C, and so and that means that that's the 2. See, so that okay, so mapping just first 0 and remaining remove just first 0, else mapping just second 0 equals 2, remaining move just second 0. Okay, so at that point we've got that, and what's more, we said that 5 and 6 are the two that only have the bottom one, right? So let's say 5 and 6 equals just second. Otherwise, 5 and 6 equals just first. Okay, so right now the rest. But either way, we've got 2 now. And now actually, I hate this approach. I want to make, yeah, I hate this approach. So I'm just going to comment this out and try again. I want to figure out what the segments represents. So let's say collections import counter, and then let's say counts equals counter C for digit in digits for C in digit. So now I want to count how many times each of these things occur, right? And I know that, so let's see how many times each of these occurs. A occurs 1, 2, 3, 4, 5, 6, 7, 8. B occurs 1, 2, 3, 4, 5, 6. C occurs 1, 2, 3, 4, 5, 6, 7, 8. D occurs 1, 2, 3, 4, 5, 6, 7. E occurs 1, 2, 3, 4. F occurs 1, 2, 3, 4, 5, 6, 7, 8, 9. And G occurs 1, 2, 3, 4, 5, 6, 7. Okay, so let's group these together. This is probably an easier way to do it. Okay, and so mapping equals this. For wire in A, B, C, D, E, F, G, and let me start with this mapping. Mapping equals this for wire in A, B, C, D, F, D. So if counts wire equals 4, mapping wire equals E. Elif counts wire equals 6, mapping wire equals B, so that's good. Elif counts wire equals 9, mapping wire equals F. Okay, and so now we need to figure out the last 4, which are D, G, C, and A. Okay. And so can we figure out and so now just care about A, C, D, G, and let's see which one has which of them. One has AG, no, that's 0. One has none. 2 has, no, 1 has C. 2 has C, D, G. 3 has C, D, G. 4 has C, D. 5 has D, G. 6 has, oh, I've been skipping A, haven't I? 2 has A, C, D, G. 3 has A, C, D, G. 4 doesn't. 5 has A, D, G. 6 has A, D, G. 7 has A. 8 has A, C, D, G. And 9 has A, C, D, G. Okay, and so what I can do then is the following. I can find C by looking for the 1. Okay, so find C. Okay, and so remaining equals wire for wire in, yep, okay, good. So find C. So first, by finding 1, okay, so 1 equals next D for D in digits if if len d equals 2, right? So I find 1, and then f is already spoken for. So c equals next ch for ch in 1 if ch in remaining, and then mapping c equals c. Good. Okay, so find c, that's good. And now now we can find a by a is the only one that appears 8 times. Find a, only one remaining that appears 8 times, and then a equal next ch for ch in remaining if count ch equals 8, remaining dot remove c, mapping a equals a, and remaining dot remove a. Okay, and so now the only thing left are d and g. And what I need to do is so I want to say the only ones I haven't done are D and G. And so let's find how many D and G's are left. And so find D and G by looking for digits with only 2 remaining. So D and G are no, that's not right either. So the 2 remaining are, oh gosh, I've confused myself. Oh, I hate this kind of problem. All right. So I want to find D and G. And I know they both occur 6 times. And I know that but I know that D occurs in the 4, and the 4 is easy to find. And so find D by looking for the 4. Okay, so 4 equals next D for D in digits if len D equals 4. Is that right? The 4 has 4 digits? Yes, it does. So that's easy enough. And so then I know that D equals next ch for ch in remaining if ch in 4. Mapping D equals D. Remaining remove D. That's good. G is the only one left. Okay. G equals remaining 0. here we'll do this. G comma equals remaining mapping G equals G. Okay. So print mapping and no, for display in displays, decode display. So let's just try that. Okay, so that didn't work. Let's try that again. Digits counts equals this mapping if counts wire equals 4. Let's print the digits because there should be one with len d equals 2. Oh, okay. Sorry. I need to do 0 here because I'm decoding those. And now let us do that. And okay, so that's fine. And now let's say number equals raw splits -1 splits. I'll call that raw number. Okay, and so now what I need to do is def remap digit, which is a string. Yes, but what I want to do is I want to sort it because that'll make my life easier. So I'm going to remap it, and then def wires to int, or let's say wire to int, no, wires to int, wire string to int. That's good. And now because I sort it, I can do basically A, B, C, E, F, G goes to 0, and C, F goes to 1, and A, C, D, E, G goes to 2, and A, C, D, F, G goes to 3, and B, C, D, F goes to 4, and I'm sure I'm screwing this up. A, B, D, F, G goes to 5, and A, B, D, E, F, G goes to 6. But if I screw this up, I'm out of time and I'll have to pick it up later. A, C, F goes to 7, and A, B, C, D, E, F, G goes to 8, and A, B, C, D, F, G goes to 9. Okay. Okay. So now actually let me make these. It'll be easier if I do it like this. Okay, and so now what I'm going to do is uh, value equals int of or let's say wires equals this, return wires to int wires. That's good. Value equals int of this dot join remap digit for digit in raw number, return value. Okay, so assert sum decode display for display and displays equals 61229. All right, let's see if, why does this keep happening to me? Okay, there's no way this is going to work. Holy cow, it did work. All right. I want to print the digits. I'm actually really amazed that that worked. Print sum. Did I actually put an assert in there? I did. Wow. I am amazed that that worked. And if that worked, probably this one will work. That is the right answer. Wow. Okay. Got in under the wire. So anyway, so this was my aborted attempt where I tried to figure out like which combination of characters corresponded to which digit. I'm just going to delete that. No one wants to see that. Wow, I'm still so Copilot didn't do much today, obviously. I'm really amazed that that worked. Wow, I really am amazed that that worked. So anyway, the first part was straightforward. They told you exactly what to do, so I don't want to dwell on that. The thing about the second part was really one, leveraging the first part to say. Actually, no. The thing was to take a different approach and say, let's count how many. So they gave us basically these things are going to be your 10 digits, right? And so we know how many times each of these wires gets lit up. And so what that means is that you know, the thing that only gets lit up 4 times has to be E. The thing that only gets lit up 6 times has to be B. The thing that only gets lit up 9 times has to be F. So then we're just left to deal with these 4. And so what did I do? So I started off by doing these that were unique. And then what I did is I said, let's find C by finding 1, right? And so how did I do that? Because F was already found. So if I find 1, there's only one thing that's left because F is already found. So that thing that's left has to be C. So that was good. And then, once C is gone, the one that appears 8 times has to be A. So then I do that. And then finally, I looked for this 4 and said, Um, why did I do that? I did that. Oh, wait, I don't, I don't remember my logic. Find D by looking for the 4. Um, and so I said, um, here's what I did. I said, I know I can find the 4 because it has only 4 segments lit up. And then I know that, of the two that are left, D and G, um, only D appears in the 4. So I find the 4. I say what is not spoken for. That's got to be D. And then finally, whatever's left is just the only one remaining. Um, and then what I did was I just basically, because these things could be in any order, I sorted them so they'd be in alphabetical order. And then I made this little lookup table and looked them up and got in under the wire. This is one where yeah, it's like a logic puzzle a little bit. Is there maybe a brute force way to do it? There probably is. 10 factorial is not that big a number, but it was kind of fun to puzzle this out. So um, yeah, it good good for me for getting it in just under the wire because I have a meeting soon. So anyway, uh, thank you for uh, watching, and I will be back. I'll be back tomorrow. I think. Yeah, probably tomorrow.